A rectangular loop has a sliding connector PQ of length L and resistance RQ. This is basically PQ and this is an entire length L, and it is moving with a speed V as shown. Now it is moving towards the right. Now the setup is placed in a uniform magnetic field going into the plane of the paper. That means into the plane of the paper, right? Now the three currents I1, I2 and IR, basically these are the currents that are given, the directions are given. Now we have to calculate the values, right? Now if a rod is moved inside a magnetic field, we know that an EMF will be generated. It will be equal to what? VBL, right? Now if you go by Fleming's right hand rule, basically you will be able to calculate the direction of the EMF, right? If I see over here, it will be like this, upward direction, right? So a current will be flowing into it now. If I use Kirchhoff law, let us first of all redraw it, or rather we do not need it. Now this will be the EMF, E will be generated. Now if I use Kirchhoff loop in this one and in this one, right, we will be able to solve the equations. Now how we will be solving the equation? Let us assume over here this is I2 and in this branch it is I and this branch it is I1. So that means E will be equal to I2 into R plus I into R. This will be the first equation, and in the second equation E will be equal to I1 into R plus I into R, right? This will be the second equation, right? Now from these two equations, if I subtract these two equations, what will I get? I will get I1 will be equal to I2, right? And we also know that since this is the junction rule, at this point the currents going in will be equal to the currents going out. That means I1 plus I2 will be equal to what? I, right? This is the third equation. So this will give me that I will be equal to twice of I1 or equal to twice of I2, because I1 is equals to I2, right? Now if I put these values over here and I calculate, I will be able to get that I will be equal to 2E by 3R, right? And I1 will be equal to I2 will be equal to E by 3R, right? And E is what? BBL, right? So that means option B is correct. I1 equal to I2. We can, in fact, in the starting itself, we could have easily eliminated option A, right? So this could have been easily eliminated, and hence, if we calculate the entire thing, option B is the correct answer. Although this was less question, this question was less of magnetism and EMI. This was basically of electric current, how to solve electric current, right? So this was basically electricity question, although it included concept of magnetism as well, right?